Hi students, in this video I'll be going through the 2021 O-Level Additional Mathematics Paper 1 question 14. Alright, so let's read the question. So a diagram shows part of the curve y equals to 4 plus 3x to the power of half. Okay, the point P44 lies on the curve and the normal to the curve at P meets the x-axis at Q. Right, so this line PQ is the normal to the curve at P, right? So they want us for 5 marks to find the coordinates of Q. Okay, so we already know that Q is on the x-axis. Alright, so the y coordinate of Q is going to be 0, right? So all we need to do is we need to find the x coordinate. Okay, but in order to find the x coordinate of Q, we will need to be able to have an equation whereby we can substitute y equals to 0 inside. And what is this equation going to be? Right, so this equation is going to be the equation of the normal to the curve at P, because this point Q is where the normal to the curve at P meets the x-axis. Alright. Okay, so our immediate aim now would be to first find the equation of the normal to the curve at P. Right, so how are we going to find the equation of normal of the curve to the curve at P? Okay, so we already know the coordinates of P, so we just need to know one more thing, which is the gradient of the normal. Right, so if we know the gradient of normal, we know it passes through 0.44, we can find the equation. So how are we going to find the equation of normal? We will need to find the equation of the tangent first, right, at P. Right, because the tangent is perpendicular to the normal. So if we know the gradient of the tangent, then we also know the gradient of the normal. Because the gradient of tangent times the gradient of normal is going to give us a result of -1, right? So the product of the gradients of two perpendicular lines will be equal to -1. So how are we going to find the gradient of tangent at P? We are going to do dy dx, okay, because dy dx will give us the gradient function. Then we're going to sub x equals to 4, because at point P, the x coordinate is 4, right? So let's carry out this plan, right? So find the coordinates of Q. So let's first find the gradient of tangent. So in order to do that, we need to differentiate, find dy dx for the curve. Right, so dy over dx is going to be so use chain rule, bring the power in front. Okay, reduce the power by 1, differentiate inside the bracket, and then multiply outside. So differentiate inside, you just get a 3, right? Okay, so I'm going to put in this form 3 over 2. Okay, bring the 4 plus 3x to the power negative half down, become 4 plus 3x to the power half. Power half is actually a square root, right? Okay, so dy dx is what we're going to get for y dx. Okay, so we're going to sub x equal to 4 inside, and that will allow us to find the gradient of tangent at P. So at P, x equals to 4. So dy dx is going to be 3 over 2 square root 4 plus 3 times 4, right? So it's going to get 3 over 8. Okay, so this is the gradient of tangent at P. Okay, so gradient of tangent at P equals to 3 over 8. So the gradient of the normal times the gradient of the tangent at P is going to give us -1. So in other words, gradient of normal times 3 over 8 equals to -1. So the gradient of normal is going to be -8 over 3. Okay, so once we know the gradient of normal, we can then find the equation of the normal PQ. Then after that, we sub y equals 0 inside, we can find x coordinate of Q. Okay, I'm going to continue over here. Okay, so equation of PQ, okay, the normal PQ, okay, will be y minus y1. So the x coordinate, y coordinate of P equals to m x minus x1. All right, so y minus 4. So open the bracket first. Okay, minus 30 plus, okay, minus and minus become plus 32 over 3. Then we bring the 4 over. Okay, so 32 over 3 plus another 4, which is 12 over 3. So that will give us 44 over 3. Okay, so this is the equation of normal PQ. Right, so at Q, okay, Q is on the x-axis, so y will be 0. Okay, so we're going to sub y to be 0. And then we solve for x, right? So 8 over 3x equals to 44 over 3. So x equals to 11 over 2, right? So x equals to 11 over 2. So therefore, coordinates of Q equals to 11 over 2, 0. Right? Okay, so this is how you find the coordinates of Q. So it's 11 over 2, 0. Okay, the next part, find the area, part B, find the area of the region bounded by the curve, the normal PQ, and the coordinate axis. Okay, so basically they want us to find this shaded area over here. Okay, so if you look at this part of the question, the shaded area can actually be divided into two regions. Okay, so for the first part of the region, okay, let's call this area region 1, and this one is region 2. Okay, so for region 1, we're going to integrate under the curve, right, from 0 to 4, okay? Then for region 2, okay, we're going to, it's just a triangle if you look at it, right? So what we can do is we can find, we can use half times base times height. So remember, we have already found the coordinates of Q to be 11 over 2, 0. Okay, so we can find the base length, then the height will just be 4, right? So let's go ahead and find the area of the shaded region. Okay, so area of shaded region. Okay, so we're going to integrate the area under the curve. Okay, we're going to integrate the curve, okay, from 0 to 4. Okay, to find the area of region 1. So 4 plus 3x to the power of half dx plus, okay, this area of triangle, half times base. Okay, so this will be the base, which will be actually 11 over 2 minus 4, right? Okay, and then the height will just be 4. Okay, just the y coordinate of p. Okay, times 4. Okay, so not too difficult. Okay, so let's integrate this. So for integration, we will add 1 to the power, so we get 3 over 2. Then divided by 3 over 2, the new power. Differentiate inside to get 3 and then put it, divide it below as well. Okay, then this one we will get plus half. 11 over 2 minus 4, which is 8 over 2, so they'll give you 3 over 2, okay, times 4. Okay, then the next part, let's tidy up the inside a bit. Okay, so 3 over 2 times 3 will give you 9 over 2. So if you divide by 9 over 2, it becomes 2 over 9, 4 plus 3x to the power 3 over 2. Okay, then for this one, we'll just get 3, right? Okay, half times 3 over 2 times 4. Half times 4 gives you 2. 2 times 3 over 2, you'll just get 3. Alright, so this one just be 3. Okay, let's sub in the numbers now. 3 times 4, 3 over 2 minus 2 over 9, 3 times 0, 3 over 2 plus 3. Okay, so for this one, 3 times 4, 12, 16. Okay, 16 if you square root it, okay, because it's over 2 years, square root 16, you get 4. 4 power 3, okay, this is 3, you'll get 64, alright? And this one, 2 over 9, 4, you square root 2, you get 2. 2 power 3, you get 8 plus 3. Okay, so over here, if you compute this out, you will get the answer 15 and 4 over 9 units squared, right? So this would be the answer. Okay, so not too difficult. Okay, so whenever you have a shaded area, just divided it divide it into different regions, and then find the area for each region, and then sum it up together. Right?